Well, welcome everybody to this session about the practical implementation of the IADOC framework. And we're going to discuss as well about future direction. And I'm going to give the floor to Barbara, who is going to give an introduction to the IADOC.
Hello everyone, I'm very happy to present to you the outcomes of IADOC. IADOC is a working group that started officially in 2019, but unofficially we already started in 2018. So it's quite a long way till we got to our output recommendations. So we have endorsed, RDA endorsed recommendations in the meantime, and we are now in a maintenance mode. This means that we have not stopped at all. What we have now is quite a good basis to continue to work on this. What we could reach in the 2 to 3 years is to build an ontology. You can see it here. We have built an IADOC ontology and the recommendations, and the whole is the IADOC framework, and everything can be found also on a GitHub repository of this. And as I said, we are in maintenance, and what we are also doing is we are really applying the framework now in different contexts, research infrastructures, different use cases, but we are also extending the framework as we see fit. And at the moment, we are also discussing one specific extension, which I will present. Yeah, sorry. Important. We are 4 great ladies co-chairing this group, and one great guy here, Seko Schindler, who supported us technically very much, and he's very valuable for us. But we have more people that are part of the core group they are mentioned here. So I am I'm a freelancer now, but I have worked for the Environment Agency now for GoFair Foundation. Gwen is very important. She is responsible for the NERC vocabularies, and we have Maria Stoica from the University of Colorado, and Maria Ana Soria de Barrayo. She works now at TURN. Yeah, in Australia. Yeah, just to say, lots of people collaborating and lots of other contributions that are not all mentioned here. Many people interested in this. So these are quickly the 5 recommendations. We focus on observable properties, on what is being observed, and not on how, where, only on the what. And this are for us the observable properties. What we want is to make them human and machine readable. We want to make these descriptions as explicit as possible. We want to make them, we want to reuse semantic artifacts to describe them properly. We want to decompose them using the IADOC ontology, which is be understood as a bridge ontology. And then we use a terminology that uses this decomposition approach. Yeah, and you can use a lot of different terminologies that are out there. You don't have to stick to one. You can do whatever fits for your need, but complies with our recommendations. And here is an example. You have an observation. We concentrate only on the what, not on the feature of interest, so not where it is, and not on the how, the procedure, although this is all important, but our focus now is on the what. So the central part, the yellow part, that's the variable, but we want to decompose it and make it very precise. And this decomposition is based on the IADOC ontology. Yeah, and underneath you can use any term from semantic artifacts. And the semantic artifacts are not one, but any you can find which are useful in your domain. So this approach is not just for environmental research, it's across domain approach. But I must say it's proven in the environmental research, and we have still to prove it if this works also for the health domain, etc. Because there are probably other difficulties that we might see. This is a very easy ontology, which are made up to 4 concepts and 6 relationships. And it's very easy. You have the variable, you have the object of interest, you have the property, you have entities, and entities can have different roles. The object of interest, the metrics, or also the strings. That's the whole ontology. It's not difficult. It's a bit difficult to understand at the beginning, but you will see some examples today. We are sure that this framework will help to semantically describe variables in a fair and machine-readable way, to decompose these descriptions by linking to existing vocabularies, providing abstract, reusable semantic descriptions, and enable mappings between variable descriptions across terminologies, because this was our goal at the very beginning. And this does not require that you change your terminologies. You have to augment the descriptions. That's what we want. In such a way, we are able to boost findability, interoperability, but also reusability of variables. And this is what you can find in GitHub. We have also a catalog of terminologies, including a unit to property lookup, and some supplementary material. We are working on variable design patterns and the existing implementations. But we think that we need to be able to group, aggregate, I-adopt modeled variables via the variable set concept. And we propose these different relations. We can go into that in more detail later. Now, I just want to say that we have now 7 lightning talks, about 4 minutes, about application of the and we will start with that.
It's always really annoying. Right, thank you very much. So yeah, I should say before, so the lightning talks, the brief for the lightning talks were to keep to 3 slides as much as possible. The first slide is to present the use case we are addressing. The second is to highlight what has worked for us. And the third slide is what didn't work so well. So I'm the first one, and I'm going to talk about the implementation we did in the NERV vocabulary server. So the NERV vocabulary server is a well-established semantic repository serving terminologies for the marine domain and as well as related domains. So we were looking at 2 main use cases. So the first one was to enable interoperability between well-established parameter naming schemes. Parameter naming schemes that are quite large and complex. The first one was the CF, so climate and forecast standard names, which is used by was created by the modeling community, and it's a well-established vocabulary now. And so it's essentially for, initially it was for modeling variables used in models, climate models, but more and more they are asked to create terms for in-situ observations as well. And the other large vocabulary was the British Oceanographic Data Center parameter usage vocabulary that was mainly designed for in-situ observations, but as also atmospheric measurements and as well as modeling parameters. The second use case was the aggregation of variables into broader concepts. And this is to support concepts like or applications like essential variables, which are groupings of measurements that will address particular variables that are important for climate change, for example. And those in particular, as those develop the essential climate variable and the essential ocean variables. So if I talk about the first use case, sorry, I'll have to read my notes. The first use case is so increasingly users want to be able to access datasets that are encoded with those parameter naming schemes, and for that reason, we need to make them interoperable. Many of the terms in those vocabularies are similar, but not exactly the same. So it's impossible to actually do direct mapping from one to another. So this is why we wanted to use iAdopt to match the terms in both vocabularies to the iAdopt classes and relationships. And for the second use case, the aggregation of parameters is needed for the discovery, but also for the integration of data into data products. So users want to be able to group terms while still being able to know the original variable name that entered into that aggregation. So these aggregations are often very user specific, so they are very difficult to maintain using traditional mappings. We used to do that in the past, but we would prefer to use dynamic mappings based on the iAdopt ontology and reasoning through Sparkle queries, etc. So just to talk about what worked well, it is a very busy slide, but I didn't want to use animation, so I'm giving you everything in one go. All right, so what worked well is that basically the iAdopt framework was very easy to implement in our system. We used the functionality, which is called profiles in our vocab server, and we were able to create views that only use the iAdopt properties. And you see all what I highlighted in red circle there are actually related to what we developed specifically for our use case. So what didn't work so well is that for the aggregation of parameters, we hit a problem in that we were trying to use the iAdopt framework or the iAdopt ontology, but the problem is that aggregation of parameters very often necessitate more than just one property, necessitate more than just one object of interest. So in that slide, for example, we've got essential climate variable nutrients or carbonate system, and those actually need to map to things like for carbonate system, we need to map to pH, we need to map to concentration of dissolved organic carbon. So all those have different properties, different object of interest. So this is why we're proposing an extension to the iAdopt schema, and we've discussed it as a group, and we're welcoming input from you all. Thank you very much. So I'm now going to pass.
You should unmute.
Alison, can you unmute?
Hello, can you hear me?
Yourself and talk. Yes, very well, yeah.
Okay, great, thank you.
Go ahead.
So I'm going to talk about the implementation of iAdopt within the CF standard names. Could I have the next slide, please? Okay, so Gwen's already introduced CF, the climate forecast standard names, as a vocabulary. So it's a controlled vocabulary for geophysical quantities, which is used within the climate and forecast metadata conventions. The conventions were originally written in around about the year 2000 from the need to share climate model data primarily. The vocabulary has grown as climate models have increased in sophistication. And as Gwen mentioned, it's also been expanded to include observations. Now, although many of the variables are atmospheric in nature, climate science, of course, by its very nature, is multidisciplinary. This is sometimes referred to as realms. So the vocabulary contains not only atmosphere quantities, but also ocean quantities, sea ice, land ice, soil, vegetation, every component of the climate system. And all those components can interact with one another, which is what my sort of top diagram represents schematically. The other feature to be aware of with model data is that the data are usually presented on a discretized grid. So that might be something in latitude, longitude, or some other horizontal coordinate system, and similar discretization in the vertical. And this does affect the way that the variables are presented and used. So we'd like to be able to map CF standard names to other vocabularies. So Gwen has mentioned the BODC parameter usage vocabulary, which again contains both modeled and observed variables. We'd also like to be able to map to other vocabularies that are used in climate modeling and also operational meteorological modeling and forecasting. So CMIP and GRIB are two vocabularies that are used in those communities. Next slide, please. So what I'm describing today is still very much work in progress, but certain parts of the vocabulary we think are very easy to map to the IADOPT framework. So for example, simple physical state variables such as air pressure and wind speed, so you just have an object of interest, and a property, chemical abundances, things like mass concentration of oxygen in seawater, so you've got an object of interest, a matrix and a property. And we can also do that, extend that to even slightly more complex things like carbonate expressed as carbon in seawater. So this is something where you're measuring the mass of the carbon inside carbonate compounds. We can express that by using a context object or context substance. And we can also represent different physical and chemical processes. This is very important for model data, because they don't just represent variables that you might go out and measure, such as air temperature, but the models themselves calculate things in a stepwise manner. And so you can have things, for example, a variable here, tendency of air temperature due to convection. You could have one that's due to precipitation, due to radiation, and so on. And so you have all these different components of the model, and you would want to be able to represent those variables. And all of those can be mapped very successfully with the current IADOPT framework. Next slide, please. But as I said, this is very much work in progress. So I didn't really want to say what didn't go well, but just to say talk about some of the challenges that we're facing in trying to map CF to IADOPT. Some of these challenges, I think we can be confident that we will be able to deal with. Others I'm a little bit less sure about, so it would be interesting to get people's thoughts about that. So the first challenge is what happens if you've got a very complex or a theoretical object of interest. By theoretical, what I mean is that in models, we can calculate variables using a formula or an equation that don't necessarily correspond to something that you could go out and measure directly in the real environment. So my first example on the slide is this long string mass concentration of absorption equivalent black carbon of PM10 dry aerosol particles in air. That's a real CF standard name. And as you can see, it's a long string. You say, wow, what does all that mean? And so actually, some of the decomposition to IADOPT is quite straightforward. So we can say that the property is mass concentration, the matrix is air, and there are two constraints that have been applied to the particles, so that the aerosol particles are dry, and they have an aerodynamic diameter that's less than or equal to 10 micrometers. But then what about the object of interest? What's the thing that's actually being observed? And at first glance, you might be tempted to say that we should just split out carbon or black carbon as a chemical species and map that to a chemical species in other vocabularies. But in fact, all of the words there that I've highlighted in blue are parts of the object of interest in this instance. And the reason for wanting to keep all of those terms together is because absorption equivalent black carbon has a very specific definition. So it's a very strongly light absorbing material. It's detected using a particular optical measurement technique. And so simply to equate it to just a chemical species isn't necessarily the most accurate kind of mapping. Because a chemical analysis would give very different results to this optical measurement method. So while this isn't a weakness of the IADOPT framework itself, it does illustrate that care is needed when you're applying it to individual variables. And domain knowledge is very important because we don't want to create spurious equivalences or mappings to other vocabularies, things that aren't scientifically accurate. The second challenge that's already been, units have already been mentioned. I think Gwen or Barbara already mentioned this. So we do need to be able to link to units information, although that isn't part of the IADOPT ontology itself, and that's a deliberate choice, I know. But for example, we have standard names we would give different standard names to concentrations which have different units of measure. So we need to be able to preserve that information. The fact that IADOPT works well with other vocabularies is useful here. There's a question about what happens if you've got two matrices, though. If you've got the idea of some sort of flow from one matrix to another, such as a flow of carbon mass into soil from decaying leaf litter and leaves. How do you express that in the framework? I've not really tackled that yet. And also there's a sense of a direction of flow. So we need to be able to have information about a sign convention. Also being able to combine things like vector components of a wind speed using a formula. So the complex property model, for example, does have this kind of concept, but currently we don't, that's not really present in the IADOPT ontology. And then also generally the representation of mathematical and statistical operations. So I'll stop there. Thank you.
All right, thanks, Alison. Thank you. The next talk is about the implementation with the SEIA Oscar Thesaurus, and it is going to be presented by Charlie Cosa on behalf of Veronique Schaffer. Charlie, can you unmute yourself, please?
Yeah. Can you hear me?
Yep. Hello.
Hello.
Yes, we hear you very well.
Yeah.
Go ahead.
Perfect. You can go next slide then. Yeah. So thank you, first of all, to give me the opportunity to present our implementation of IADOPT in SEIA Oscar information system. So a few words of context. This is a system that is currently under construction, and it aims to facilitate the use of all in situ observation data on continental surfaces that are collected by French research organizations. So our use case for using IADOPT framework is that we need to expose data from heterogeneous sources on a single data portal. And those data sources are for the moment 21 long-term French observatories that monitor a large diversity of variables. And as those observatories are long-term and they all come from different historics, they all have their own way of describing variables. So for example, each observatory is monitoring precipitation amount at some point, but none of them are naming this variable the same way. So with this data portal, we want to facilitate the data discovery by providing research criteria using harmonized variable names among all of the observatories. And as this system is also dedicated to be interoperable with other information systems, we want to provide rich information on variables to enhance data reusability and interoperability. And so for this purpose, we decided to create our own controlled vocabulary and to describe variable with IADOPT in this vocabulary. So next slide, please. Can you go next? Wait, perfect. So what worked well is that we managed to, I like to mention that we managed to implement this framework on our vocabulary using available online resources only. So using the GitHub, the papers and talk from YouTube. For us, it's generic enough to model all of our variables. So we have a large set of environmental variables, but also chemistry and physics variables that come from geophysical measurements. So sometimes it's not so straightforward, but in the end, we managed to model all the variables. But yeah, we should probably discuss with Alison because we have, I think we have similar variables, and it could be interesting to see if we if we have the same conclusions. One other benefit of this implementation is that it has enriched our vocabulary with other concepts, and we are now thinking of making newer discovery dimensions in our data portal with those newer concepts.
Yes, 1 minute, Charlie.
Yeah. So yeah, I want to mention that we are using this framework with viscose hierarchical relations to provide categorization. Since all those variables are describing time series, we are using CPM ontology classes to describe time aggregation as well. Next slide, please. So with all this information, we have, I think, documented rich information on the variables that satisfies interoperability needs, but variable labels are often too complicated to be used directly for data discovery. So we decided to implement our own simplified label to aggregate complicated variable name under a simpler label for the user of the data portal. And one question that remains is that sometimes when you model the variable, different implementation of iAdopt are possible, and we are wondering why we should choose one or another, and in the end, how we will be able to identify similarities between identical variables that are modeled differently.
Right. Yes, that's great. Thank you very much, Charlie.
Thank you.
Thank you, Gwen. So now I will present how we in ELTA, long-term ecosystem research infrastructure, are going to use iAdopt to describe our variables. It's a work in progress. I started 2 weeks ago, and I will work on this the next 2 months because we have more than 600 variables to model. So the use case is that we have now defined ELTA standard observations for 5 ecosystem spheres: geosphere, hydrosphere, biosphere, atmosphere, and social sphere. So there will be some overlaps for sure with the marine and atmospheric domains. Yeah, we call them standard observations because we have 450 sites all over Europe and in 26 countries. So it's quite huge and quite complex, and we have really very inconsistent technical conditions in on the different sites, and also it's quite a challenge to bring this together and to harmonize this. But we want to standardize and harmonize at the same time, so bottom up and top down. We think that iAdopt can help us to reach this goal and to agree on, and this was a very long process, to agree which are the minimum observations that each site should really do according to protocols and methods defined in the ELTA research infrastructure. And so we use ENFTAS for all the variables, where I'm the coordinator of this vocabulary, and we are using iAdopt in ENFTAS to decompose each of the variables. But then we are using ELTA controlled lists to aggregate them according to the new extension proposal into these ELTA standard observations, regrouped under the different this geosphere, the hydrosphere, biosphere, etc. Because we think we need this as a better way to find variables. Yeah? And this ELTA controlled list reuse terms from the from ENFTAS and decompose where these are already decomposed. So I first address what challenges we had. So I don't think it does not work well. It's more the problem that I still need much more detailed information from the community, from the researchers, because what I get from them are very coarse ideas, what they want to observe. So there will be a lot of interaction needed. I need precise information to really model this in a precise way. We have proxy observations very often. So for me, there are variables needed to describe the proxy and the intended observation. But in the controlled lists, I will use the intended observation because we need to find out about the intended observations. And in the method that we have also to tackle, we will include also the proxy observations. Well, there's the challenge that the same compartment like soil can happen to take different roles in the decomposition, can be the object of interest matrix or context object. But this is when you work precisely, you will discover that this is needed. Yeah, and so it's really important that you have detailed information. Without this information, you cannot do precise descriptions. And yeah, for example, just here an example, if you just get information concentration, it can be a molar concentration, it can be a volume concentration. So it depends really also on the units in which they are expressed. And when you have the units, you can really do the job properly. But I think overall it works well. But we have to complement this work by also providing an ontology to really constrain the observations that follow the matrix or the methods, the protocols that we define in ELTE. Thank you very much.
And next talk is remote by Robert Huber about implementation in Pangea. Robert, can you unmute yourself?
Yes, so I'm ready. I hope you can hear me.
We can hear you very well, yes.
Okay, that's great. So maybe you can just show this first slide. So yeah, Pangea is one of the largest data archives for Earth and environmental data. And here on the left part is an overview on how our data set actually looks like. We have a very complete metadata description for each data set, which includes a list of what we call parameters, which are used in a data set. So that's what IADOPT is calling variable. We use a number of vocabularies or ontologies to semantically annotate these parameters. To do this, we use a web service, which is parsing a parameter string and is identifying terms which are contained in these ontologies. And the web service is also then storing the relation between terms and parameters in a dedicated relational data structure, which is shown here on the right bottom part of that slide. So for example, we use worms or ITs to identify or to annotate taxonomic terms, like it is shown here in the example, by this link from this species name to the worms record. And so this relation between variables and terms is very useful for humans. For example, we can use this in our web interface to show these tooltips, which is shown here. So the user can see which terms are part of this parameter, and users can also follow then the link and to see the detailed record, for example, here in worms. It's also very useful for our curators for their daily data curation tasks to enable them to define or to identify appropriate terms for each parameter during data curation. So, but it is also very interesting for machine-to-machine interoperability. We have heard about this several times today. So to ease interoperability with other data archives to compare variables and parameters from others with ours. And this is exactly where you think I adopt this as a very good choice. So this all worked well in the moment. The task of semantic annotation is something we do now for several years. So this is quite nice. Can you show the next slide, please? So, but there are, of course, some challenges with respect to iAdopt. As mentioned before, we can easily match terms with parameters, but it is not really trivial to apply the iAdopt structure to these mappings. For example, it is really hard to find out which part of the parameter is an entity or property or constraint, and then it's more difficult. This is what Barbara also mentioned before, to decide if this is a matrix concept, a matrix object or a context object, and so on. In some cases, it's comparably easy. For example, if we use terms which come from dedicated ontologies like worms or itis, where we know there are only taxon-related terms, then we can just assume that this is an entity. And it is also possible, for example, in ontologies like Envo and Pato, to decide if a link is a property or a context object based on their position within the graph. But it's really hard sometimes to do this because it's also sometimes a little bit ambiguous. So next slide, please. Next slide.
1 minute.
Okay. Yeah. So our approach in the moment is to try to integrate the iAdopt during this automatized workflow and during this parameter parsing process. We plan, for example, to integrate iAdopt, the vocabulary, in Pangea's terminology service to make use of the terms of iAdopt. And we are now playing with the upgrade of this parameter annotation web service, which we try to learn or to teach to guess which iAdopt classes and roles can be applied for the detected terms. So as I mentioned before, based on the ontology like worms and Chevy, which would then be context objects, or based on the ontology position in the graph for Envo and Pato. And sometimes just based on English grammar to decide if something is a constraint. So this is what we play with, but as mentioned by the other speakers, this is really a challenge. Thank you.
Right, thank you, Robert. So next speaker is Stuart Chalk. Oh, and you're here.
Here, yes.
I can sit down.
After doing 2 presentations already today, I'm not sure I am here anymore. But yeah, thanks for including me in this. This is a very quick talk about something I've developed called SciData. It's a nominal JSON-LD framework for representing scientific data in a very generic sense. My use case is, can I make this? Can I add iAdopt to SciData to make it more tractable for the community to be able to kind of use? Because as much as I love this specification, I have to communicate to the audience or to the communities that, if you're interested in using this, how do you use this? Well, there is an ontology that describes the structure of this, but if I can obviously include something like iAdopt in the framework to represent appropriate pieces semantically, then there's more likely to be adoption. And so adopting iAdopt, of course, is the right thing to do, right? I mean, this is why it's the name. There we go. So what I'm going to show you are just a few examples of how I've integrated iAdopt into the SciData JSON-LD framework. This first one is where I have, as you can see on the left-hand side, there's an identification of the type of this information is about a chemical substance. And on the right-hand side, obviously very simply, I've added the identification that this is an entity in the context of iAdopt. Okay, so it's just an additional semantic annotation in the JSON-LD document that I'm using as this example. I can do similar things in other parts of an example document where, for instance, here I'm doing a representation of a mixture which has different constituents. But on the other side, on the right-hand side here, I can pull out those constituents that make up the actual matrix of the sample that's being measured. So I'm representing that in the top part of the right-hand side. And then in the bottom, I have now a second mixture which incorporates the matrix with the actual object of interest, which is the solute that's being measured. So although I have to change a little bit the way in which the JSON-LD is represented here, it's just to obviously pull out the piece that actually is the matrix in this context. So this still works. And then finally, as an example, when we're talking about the actual data set, the structure of SciData is such that in this section, there are some prescriptive elements that are defined, again, in the ontology. So the fact that data point, data group, data set is in the structure is actually ontologically defined so that in the graph, those pieces are part of the knowledge graph. They are specific triples that you can actually search for. So they help us actually get to certain places in the data set. And as you can see, I can update this annotation with IADOPT by changing, for instance, adding in the first instance there, the object hash, which is the nominal chemical of interest, or the object of interest in this context. I've changed what I called conditions under which this data was recorded to constraints, which is an obvious replacement. And then I've also added the IADOPT variable in the context of being an example of, or a way to represent a data point in this context. And then finally, I've added in property there because if I want to, I can include IADOPT in the context file that is used to represent or semantically annotate this data. And so my final slide here is to just show that you can include IADOPT in the context file to then provide appropriate semantic annotation of the relationships when you generate your triples. So at this point, what I've got seems to work. The only thing that I would, or two things that I would say is, one, I think we really do need variable set, but that's for discussion. And then two, there has already been reference to units of measure a couple of times. And I think units of measure, I don't know if we say they need to be included in IADOPT, but I think they are very important to IADOPT. And I would like to have more discussions about that particular topic. So thank you.
Thank you.
And our last speaker is Natalia Queiroz de Oliveira. Natalia, who is going to speak to us about a very interesting study she carried out using IADOPT. Natalia, could you unmute yourself? Huh? She's unmuted? No. Natalia, we can't hear you.
She need to be made a host.
She just made a comment. At least Zoom says she is unmuted, so.
Can you hear me? Can you hear me?
Oh. Hi, Natalia.
Yes.
Welcome. Yes,
Okay.
we can hear you well. The floor is yours.
Okay, thank you. Hi, everyone. I'm Natalia, and I'm going to share with you a little bit of my PhD study. And first of all, I would like to thank the IADOPT group for the invitation and also the space to share a little bit about what I've been studying. So next slide, please. Thank you. So in the end of the last year, we have the opportunity to present our study about analysis of observational variables from an ontological patterns perspective. In the 50th edition of Ontobras, there is a Brazilian seminar, a scientific seminar to talk about experience, methodologies, and theories in the practice of ontologies. So in the paper, we present the use of a measurement ontology pattern language, MPL, in the I-adopt framework ontology. So MLPL addressed the core conceptualization for measurement according to an ontology pattern language that provides a guidance of how to use and integrate related patterns into a conceptual model. So MPL takes UFU, Unified Foundation Ontology, as basis. So UFU was developed by combining a number of micro theories from the areas of philosophy, cognitive science and linguistics. And over the year, UFO has been employed for analyzing and engineering of many different ontologies and in many different domains. So it is important to highlight that how well-defined variables make data easier to find and reuse. And increasing semantic interoperability of a variable is still a challenge. So the goal of our study was to semantically enrich the I-adopt ontology using MLPL as a reference. So doing so, it is possible to clarify and capture the conceptualization of measurements for a compound concept variable. So first, we apply 5 MLPL patterns groups, and in the link of the work, you can see a lot of details of how in the process in order to apply MLPL. Next slide, please. Thank you. So by aligning the I-adopt ontology to the core modeling patterns proposed for measurements, we aim to capture the conceptualization of measurements for a compound concept variable. And moreover, this alignment can help to represent concepts not yet addressed by the I-adopt ontology, such as scale, units, measurement procedures, and so on. So the goal is to semantically enrich the ontology and using MLPL as a reference to do so. Next slide, please. So doing so, we have a lot of benefits. So we are able to identification of some concepts and relations that are semantically overloaded in the ontology. We can do the alignment of the with the measurement, the core measurements, and also an extension to represent concepts that not yet are addressed now by the ontology. So we have a lot of benefits, a set of benefits. And as victory work in my PhD, I pretend to continue to use these ontological patterns to represent qualitative variables, and also to maybe explore more applications of measurement OPLs to increase semantic interoperability in this domain. So thank you so much.
Thank you. So we're now going to open the floor for questions. So the first reaction, any questions related to the talks you've just heard? Anybody wants to start?
We start here in the room if you have questions. Yes.
Hi, thanks you guys for presenting all this. I was curious about the challenges that came up a couple times, the issue with only being able to specify one matrix. Has the group talked about maybe trying to tackle that in the future, or maybe it's just a misunderstanding that hasn't.
So what's the exact question?
So the question was, in the ontology, you can only specify at least one matrix, right? And a couple of the talks mentioned, we kind of have a couple matrices. We'd love to specify that, or there's like a...
No. So I think what I mentioned is that the same term, soil, for example, can have different roles in different variables, because you have different measurements. And this makes totally sense to me. But what I have heard is also that it's still difficult to apply that, to really understand how to apply the ontology. And I think it's a matter of just doing the work very frequently and understanding the logic, because we are in a core group, we are convinced that once you understand the logic, it's not difficult to identify exactly the different roles. I think it's a bit another way how you should do it, but we need syntax, and the syntax really starts from the idea that we measure a property of something specific, and you can always find what the object is. But what we should probably do is more offer workshops, work collaboratively on the modeling, just to show how this works.
Yeah, I think I should add, yeah, it's arriving to a common understanding about how best to use iAdopt. Because it's true that, you know, it is subjective somehow, but there's still some, yeah, pretty clear logic about, but it's where to draw the line between, you know, when you've got a complex, you can have complex objects of interest. Where do you draw the line? But I think for most of the variable we've been working with, at least in the environmental sciences, by working together, we can come up with a
common logic,
a common understanding, yes,
but I
and best practices.
But I can also say that in the health, so it will be possible to do this in many fields, but probably there are limits in the health domain, and we are discovering this. Yes, please.
Yeah, I think it's a perfect segue when you said about workshop coming from, let's say, engineering domain, and if you would go to an engineer and tell him, well, you have to specify your variables in iAdopt framework. Most of the engineers would go like that, and there is no way you would expect them to do that, in the sense that they would not know how to model, how to approach. So like workshops would behave like it's just that the threshold is so high for me between representing some, like I just have a problem. I need to give some data to someone, and I want to represent the variables, right? And and I started to look. Well, okay, let's use some ontology, and then I see, oh, there is iAdopt, and then I see there is SciData, and then there is other one. I just write it in English.
And you are perfectly fine with that, because at the end, we don't expect researchers to do this. We are all vocabulary managers. So
at least not initially.
Yeah. Let me finish, and then you can complement. Yeah. Because my idea is really, at the end, we will have a nice application where you just write your English sentence, what you are measuring. And the system will suggest a decomposition and ask you, are you happy with it? So can you recognize your measurement? And everything else is done by the service. That would be great. But first we have to do the hard work and provide as many as possible variables so that it can be recognized also by machine learning, by patterns that you can extract from lots of these decompositions. So that so it's more the work of semantics here, so, and together with specialists, that we can do this.
Yeah, completely agree with that. Yes, please.
Yeah, Hugo from dance. So in a previous life, I of course worked amongst others with Barbara in the environmental sciences, biodiversity, and so on. So I think one should revisit and maybe look for specific cases of this idea that some properties and variables don't belong to the entity or the feature of observation, but to a relationship between two or more entities. So something like predation or interspecies relations, that variable of measurement applies to two observed entities and a relation between them. So the variable describes things that were measured in a relationship and not for one of the two distinct entities. So it may be possible already to model. I may be missing out to do that, but I think this speaks to this idea of fluxes and stocks and flows that are not entirely the same. And in some cases, if you generalize it, relations between features that you are measuring something about.
Yes, we haven't, I mean, with iAdopt, we haven't directly addressed this case. But at BODC, we have within our own ontology. But it's something that we will probably need to look at more closely.
Yeah, I think
the relationship.
We should have a proper workshop on that. But
Yes.
For us, and that's also the critique that I always hear, that iAdopt is not well embedded in upper ontologies and so on. What I want to say is the entity for us is just to say the thing, or what we observe. What we observe can also be a process, and not only an object. Yeah? Can also be a relationship. Yeah. So you can do it already now, but we should really work on concrete use cases and discuss them through.
Yeah.
Yes. Please.
I'm Brigitte Gothenburg from Hamburg Central Berlin. And I have a question. You said now deriving these.
Louder, please.
I was wondering if you are saying deriving these you observe from a sentence, huh?
Yeah.
But could you also do? I mean, there's a specific instrument, huh?
Yeah.
And there's a specific technique you apply, and the technique, the measurement technique you apply tells you also what you can see, what you can observe, and then also if you have a certain energy range, and then you have the information of the sample, and maybe in the sample you want to. Maybe you know what you will see. You're looking for a certain concentration of a certain thing in a certain thing, so that you have like some kind of what is it, like a two-component box. You can compose it together somehow.
Yeah, that's our dream. So we are not yet there, yeah, but we want.
But what I think is maybe it's for some research areas it might be more easy than for others maybe.
Yeah, for sure. That's for sure. So we already discovered difficulties in some other areas, but you can also derive your property from the unit, or it can help you to derive, yeah. In some sort, yeah, you will help us, right? We are not specialists here, but you can discover a range of possible properties that you can derive from units. But there's the BitInst working group. They have addressed the variable as a black box, but they think to use iAdopt variables to make this very precise. So at the end, we hope that having an instrument, you have also the information about the variables that this instrument is able to detect. Yeah. And what is also important, iAdopt is one small piece in the whole picture. So you need an ontology, you need an observational ontology or something like that to really address each aspect. And why are we not yet including units? Is because we think a variable can be expressed in different units. Yeah, it depends really, you can have different variations. But in standard observations for ELTA, we will make a variable with a unit. So we will just put it under the hierarchy of a iAdopt variable. We will have different units with specific.
It's an additional attribute. To the
an additional attribute. Yes. Any other question? Yes.
Sorry to hog. One point is to follow up exactly like that we do need ontologies, like already I think there already exists the sensor ontology for the semantic web recommendations. Have you tried using iAdopt to represent the concept of uncertainties that is always very often goes together with the observation? Have you already tried to model it?
I know there are people, I'm not sure, yeah. We have people here that work in this uncertainty and quality measurements, and we want to include this, but it's not yet part of the work done so far. So, and I don't think, well, we will have to address this, how to use it, but we are not going to remodel this. So,
Yeah, of course. I'm minimal ontological commitment all the way. Everything should not be in part of the model.
Just to follow up on that comment, just for those of you that may not know this yet, the BIPM, the CIPM, that's in charge of the SI is undertaking a digitalization effort of the SI right now. And the work plan on that will start next year. The point is, the metrology community is going to digitally model metrology. And so that will include not only units, but quantities, scales, uncertainty, and all of those topics. So now, it may not be quick enough for everybody, but they are going down this path. So it's a good thing.
At least we'll be able to use that as a reference, as a point of truth.
Yes.
Excellent.
but it will be interesting to look into the work of Natalia, who works with the UFO people, and I am also a PhD student, although already old, but anyhow, I have to see how I tackle the UFO problem, because my boss is actually the inventor of UFO, Giancarlo Itzadin. He wants to see IADOPT embedded there, so we'll see how we do this. I think it's important to just understand how this relates and how it can be applied in a wider context. Please.
Yeah, so maybe just another thought. How does one go about determining where the definition of a variable stops and where the definition of something different, such as a unit of measure, begins, and where the instrument definition begins? Because this problem occurs also in other fields around research, data management, and ontologies and vocabularies and metadata, because the stuff creeps into one another and it becomes difficult
and that's
to
exactly
maintain.
the topic of my PhD. So if you have time to wait 1.5 years, so
I think some of that can be easily answered because, for example, a sensor can observe many things,
Yes.
and when you actually put it in the water, in our case, you may have switched off a few of the outputs, and so I would put a data set that observes. I would separate the observable property totally from the units, because you have a certain unit for the specific measurement you made, and maybe the observable property could have the applicable units. So has these units that could be applied, but I select this one. So you have a drop-down list in the end of things that you could be using. And your sensor could be observing all of these, but for this particular measurement, I chose this one in this unit of measure with this value.
And in the US, it's a different unit of measure.
Not if they adopt the SI.
GDT is already there. Yeah, and it's not digitized and fair.
Just like one last mention, there's the observation measurement. It's a OGC standard that will have now a version 3. And a colleague of mine, or a former colleague of mine, is working on making the specification online very soon, and they are already including IADOPT to make the observable property more precise. Yeah, because they also see the problem that you can define everything with a observable property if you don't have a syntax. Are we already closing?
No, it's just because I was asked to step away from the desk.
Yes, please.
Interferences.
Go ahead.
So, do you have cases for where the entity that is doing the observing is not a machine? So, as a social scientist, I am observing, observing people, and I am prone to error myself. So where I don't necessarily have a clear structure for defining the observation process itself. Has it been taken and applied in those? So psychologists, sociologists.
Yeah, the social sciences are very, very challenging for us. But I am an ecologist, so in the landscape ecology, you have also very soft variables where everything is a little bit fuzzy and not so precise. I understand this problem, and I must say, I don't want to say too much about this, but I work at GoFair Foundation, and we do a lot of M4M, metadata formation workshops, and one format is IADOPT. So, and there we are working, for example, with social sciences, health domain sciences, and probably we will detect that IADOPT doesn't work for everything. So that's also fine, but then we need another syntax that we could find useful for these domains.
And that could be almost interoperable, where it can be interoperable as well.
And yeah, we can see then how we can refer to each other. Yeah. But I think work needs to be done in this direction. Yeah.
I think we must say our working group was dominated by environmental scientists. So obviously, and we knew there was already material there we could work with as well. A lot of work had already been done over the years, so it's.
And by the way, from the health domains, I have already found similar approaches. But obviously, not everybody in the health domain knows about it. So this has to be discussed and propagated. Yeah. Yes, please go ahead.
Yeah, so I mean, now that I'm embedded in the social sciences, I'm keen to collaborate to see how we can use IADOPT maybe in social sciences.
Thank you.
But the challenge is a bit more complicated because I have this unpopular opinion that half of the data in social sciences repositories are not data because they cannot define a variable.
Yeah.
Something like an audio-visual recording. There's no variable for it. So what did it measure? What is the data about? It can be analyzed for data, like how many times you find a red pixel per second, or what is the sentiment of the person being interviewed and so on. But just the raw interviews for me are not data sets because they don't have variables.
But then they are defined with using other schema on the other metadata schema. They don't fit the variable model. It's the last one. I suppose it's the same in
but
in the marine environment. There are raw materials that don't, you won't use IADOPT to define them, but you use IADOPT to define the information that's extracted from.
Yes,
from that.
that's different because these things are published as data sets.
Right. Okay.
They have no defined variable.
Yeah.
I'm beginning to say that they are digital samples.
Yeah.
Right.
Collections.
Yes.
Digital collections.
Yes.
Yes, please go ahead.
In this case, I mean, if you have like an image from a tomography, just the image like a computer, you would also, it's not data in your opinion, but I mean, we do have data. We have, I mean, also if you have an audio recording or video recording, we have like a certain frames, certain rights, and
that's not recorded in metrics.
I think it's very hard to hear for the remote people to hear anything, so you have to be very loud. So please go ahead.
A quick observation there that thinking of collections, there is a movement in sort of the cultural heritage and other communities around collections as data, and exploring that I think would be a pretty interesting sort of space to look at connecting the dots there, because I do think there are say just imaging technologies. Is that data until it's processed?
Yeah.
These are questions that there can be picked up.
Okay. Yes, please.
Just saying that in the oceanography, we also take pictures and interpret them on, for example, what kind of creature is that I see, and how many times can I see the creature in that photo, and that's enough for these people to. They have to annotate the picture and interpret it, and that's a data set.
No, sure, but that's already been analyzed then, either by a human or a machine, to say this is the count of organism X in the picture. But the picture originally wasn't data; it's a sample.
It is,
Yes. Well, everything is a sample on a fundamental level. Sometimes we're not measuring wind speed per se. We're measuring changes in resistivity of some things. So what are we measuring? Are we measuring the speed of light? This is a fundamental observable property. Everything is a sample in a certain point.
And then you have proxy measurements for the intended ones. Yeah.
You want to? Yes, go ahead.
So, I mean, maybe this is not really the right model for it, but I'm thinking a bit about highly processed data, such as the example here. And I mean, if you have a sequencing experiment, you have a device that captures imaging data from chemical processes, and then you translate that into some standard format based on statistical processes, and you end up with a classification for a position in the DNA sequence, for example. And then, I mean, it would be nice to be able to annotate how these were produced in a way that kind of could be compared across different types of devices. But I'm not sure if this is
But
really.
if you address how, then it's a procedure.
Yeah, I mean, it could be also, so that's my point a bit, like, so it's a measurement of a procedure. So it's not a kind of natural phenomenon. It's more like a very standardized process, or to a high degree, very standardized process. And it would be nice to be able to compare it in a way that different file formats encode it in different ways. Or you might have different representations of it.
That would be using a different modeling approach.
Perhaps.
Yes. Right.
So,
or I mean, an extension of something similar like this, but maybe not exactly.
Eric Schultes, my colleague in GoFair Foundation, is always asking, well, can we use IADOP for that? And I said, well, we have to find out. I'm not from the field. You guys have to sit together, and then we can think through how we can make this like a syntax so that we can apply this also, yeah. That are working with this data.
I suppose as part of this discussion as well, I mean, there's a lot of direction we could go now. I mean, obviously we need to complete, finalize the implementation of, to show that it is, in real life, it can be applied. But we've identified different directions in which we could go, like the linking with the systems of units. We are starting having use cases for more information about methodology, which obviously we can't, it would be another plug on the IADOPT ontology. So, I mean, there's lots of interest, and this.
Are you sure that's another plug, or it's that both are needed in an observational ontology?
Yes, yeah. Yes, well, yes, and they will be connected somehow, but it would be extension to the IADOPT, but not, it would sit slightly independently from IADOPT.
Yeah. And if you look at the work that Natalia did, so I understand what she's doing, but our intention was to be very simple, although it's already not very simple to apply it, yeah, because you need to understand the logic. But if you include all this, yeah, I think what she's doing makes sense in a certain extent, but it depends always, I think, on the use case. We wanted to be use case independent, and therefore make it as lightweight as possible. But I want to really analyze if this is necessary, yeah, to extend, because there are also good insights into this work. Yeah, Yeah, so I think the next time we should do a real nice modeling workshop. Yeah. With complex properties like these relationships, this also not very, it's so easy to make just the observation of a chemical somewhere, yeah, but if you have more complex compound observations, it's difficult, yes, and social.
I would say I would be interested in exploring things that are much harder to actually experience in the real world. Like we have to measure happiness.
Yeah.
Take as an example. How do you define and embed concepts of that style in that framework?
You must be making some measurements to define happiness.
Yes.
Yeah.
But you can see how smile. You want complexity. Think about the.
I thought that Bhutan has already defined what happiness means.
Yes.
they have a ministry
exactly
for happiness, they had to quantify this very qualitative, they had to quantify this, and they have the indexes for that. So happy to do that.
So people in this audience who've never attended an iAdopt session and would be interested in joining your group for pursuing some particular use cases.
Yeah, and also collaboration, so that,
Yeah, I think it's interesting for us to look at, for argument's sake, take variables in social sciences, like the stuff collected by census bureaus and so on, that also end up in our repository. We can model that using iAdopt, because that's a first start, I think. I agree, there's all kinds of other fuzzy type of data that's much more difficult to define, and in fact may not even be reproducible if some other individual or group undertakes the same process. They may come to a different data set. So it gets very fuzzy.
So I would advise, so at the moment we are 7-8 different nodes working on the same stuff, so but more environmental. Gwen is working on it, I am working on it. So we are working a little bit independent, but then we are comparing. It's important that we are working a little bit independent so that we try to see if we can find the same way to express it, and then we compare it. And if we are then able to tell the machine that it's the same thing, although we decompose it a bit differently, then probably it's still possible, but we can also enhance the model. So I would prefer to do this first and then go to other domains, because if we cannot agree on how to express things, then it's a bit difficult.
Yeah.
So this will happen in the next half year. But interestingly, Markus Stocker from TIP in Hanover, he said, please give me 200-300 decompositions, and then I will play with ChatGPT to detect patterns so that we can propose decompositions by the machine, and then let humans find out if this is helpful or not, if they went completely different. So because we need these helpers, we are not going to.
I found that ChatGPT has very high difficulty with trying to do conceptualizations.
No, in fact, so therefore you have to
provide.
Therefore you have to provide lots of input data, lots of samples.
It's just not the right tool for conceptualizations.
Yeah, we will find out, but he is really in the topic.
Unless you think humans are probabilistic machines, but then that is a philosophical
Let's
question.
talk in a year. I'm not so pessimistic. I hope that machines can help us. Yeah, I am not going to do everything, compose everything here on my own. Yeah. Okay.
When
Yes.
you were proposing a workshop to follow up on this, were you suggesting at the next RDA or outside of that? Because I would wonder.
I'm open for whatever.
Well, I would think it would maybe be more time than an hour and a half would be.
I am also happy
time
to work
dedicated.
1 week on it. But I think I will be the only one.
I don't know that I can commit that.
So you would suggest doing it outside of the RDA?
Well, I was asking you guys whether you're thinking about doing it outside of RDA.
But at the moment, we haven't really been
So
far into planning it. But,
I would like to consolidate the work we are doing. So I do now the 600 for LTR, which is already a little bit of work. Then we have to make the comparison between us, and after that, I think we are happy to do this in half a year. Yeah. And then a 2 days workshop somewhere. Not 1 week. 2 days.
It almost is a sort of a situation where people could come in and do almost a hackathon approach to implementation, so that you really
I can imagine.
You bring your
use case.
I can imagine that GoFair can help us with the organization of it. Yeah. So as I am there with them. Okay.
Before there's still
Yeah.
What, 10 minutes?
Yeah, so we can.
Any questions online?
No,
Yeah, it's just closing.
yeah, this would be nice.
Anybody online, if you want to ask a question, could you just write it in the chat, or come, or even unmute yourself? But we've got 10 minutes left, and recently, I did mention it in my 3 minutes there, but you might have missed it, but we are proposing an extension to the original by original class which were set to enable the aggregation of variables. And in order to do that, we do have, so we need this additional class and additional properties, which is as applicable property, as applicable object of interest, as applicable context object, and as applicable matrix. So this is to mirror the original properties, but to enable as well 0 to many, how do you call them? 0 to many, well, basically a variable set can, yes, relationship entities with the entities. So we are inviting comments until the end of March through GitHub.
It's also in our wiki, represented in our wiki, the whole description. And why this is, we think it's important because we want to be able to describe essential ocean variables, essential climate variables.
Go back to the slide. Go back to the slide where you show your slide where I think it has the applicable, the AOV.
No, that's just the one. That was the other talk in VSEG. But so basically, it is in order to do more dynamic mapping between an aggregation entity and a base variable, if you want. So because it is very difficult to manage mapping relationships, and also many use cases. So we want very highly described variables to be unambiguous about what is being measured. But at the same time, different users or different applications will need different ways of grouping those variables according to their own criteria. And this is, as a vocabulary manager, it is very difficult to manage all those mappings because one entity can be mapped to many, many aggregations. So what we came up with regards to the essential variable or the sustainable development goals indicators is, or even to anybody trying to create a data portal, for example, with specific aggregations targeted at their user group, is that it's best to actually give the information in an IADOC decomposition manner, and then have a reasoning on the top of that to be able to apply the criteria that are needed for the aggregation. And this is something we can't continue this idea without the class variable sets that would enable us to group base entities or IADOC variables together in a flexible manner. I don't know if there's any questions about this or need for clarification.
And I think we have to change the cardinality.
Yes.
It was an error. I did. I think we need a variable set needs to have 1 to n variables, 1 to many variables, where we should have 0 to 1 applicable object of interest and properties. Because if you put 1 to many, then you need to have, for example, soil or something like that. You have to specify which object of interest is included or not. And we cannot say it can differ because dependent on the type of observation, the roles will differ. And therefore you must be very open in that sense. But there are discussions. John Graybill, for example, was addressing this topic in GitHub. I don't know if you have responded to it. He did not reply. So there were 3 scenarios. Can you tell the 3 scenarios that he saw?
So John pretty much suggested like 3 ways of composing variables into a variable set. First one being just using this has member and then assigning each variable individually to the set, pretty much maintaining that manually over time. Second one was, in my interpretation, that via this has applicable something, you're defining constraints and then automatically collect all the variables that adhere to those constraints into that variable set, which would make it far more easier to maintain those, update those in the future. But it might also get some variables in there which are not meant to be in there. And then there was a third one, where he said that you really specify the intention of the variable set. For example, to prevent unintentional variables from coming into that. But this would require a whole lot of ontological work, how to describe that intent and say what you don't want to have in there, etc. So, yeah.
So, and what is the conclusion? What we are then now doing? Is it A, B, or C?
Yeah, so we discussed that yesterday, and we think that we are currently on this level B. So we want to have these as applicable as kind of constraints. But so far, we haven't come across a case where you would define a constraint that matches a variable, but you don't want to have a variable into the set. So if we find such a case at some point, then we have to think about it again. So far, we haven't come across any of those cases. And we think we support primarily B, so this via constraints. But as you see here, this has member, you can still do the manual stuff if you want to.
Yes, yeah.
So I will now, after this meeting, change this and explain that it was my error. Yeah, and because we have to make this clear what we are meaning, otherwise, yeah. Yes?
So going back to Alison's issue with the complicated entity, right? How easy would it be to add the idea of a compound entity that's made up of other entities to maybe solve that issue and maybe make it even a little bit more flexible in general?
Yes, I think this has to do with our discussion. We have lots of side discussions in there, so there are many issues that pop up. But we had in a table with lots of observations. You could have dependent and independent observations that or columns, and if a compound entity is dependent on previous measurements, then how can you address this ontologically? I'm not sure if you can address this really in the IADOPT ontology or in the measurement ontology. Yeah.
Can I just say, I think it also is, I think it might be a problem that needs to be resolved at the vocabulary level. So you could have, you could have an entity that's, or an object of interest as a compound. Right. Exactly, in your vocabulary, it's actually a compound concept. So, and we've got those examples in the BODC PUV, where we've got matrices that might be compound entities. So maybe, we should be careful of trying to deal with that complexity
Put it in here.
at the model level. Exactly, but then if in the future we think it's important to actually have it, dealt with a more complex relationship and really express the entities separately, then we do that, but maybe at a later stage.
Maybe a naive question, but in that variable set, does it not just inherit things like relations to the entities from the individual variables in that set? Because the diagram as it stands there implies that a variable set, for instance, can have a object of interest that is different from what can be aggregated from the variables that are part of the set. If that's the case, then that arrow should be there. But if you can aggregate the object of interest by looking at the individual variables, variables, you don't need that relationship because it is redundant.
You want to be able to group multiple.
What I'm saying is if there's two variables in a set and they are already defining an object of interest in a relation with an entity, unless you need something that is not defined in those two relationships, you don't need that top relation because you can aggregate those relations from the variable. And that's much more maintainable because otherwise you've got relations that can get out of sync.
Inherited.
So I didn't get which of those arrows could get.
So what I'm saying is variable set has a relation to entity through the object of interest relation. If that doesn't add any extra information that cannot be aggregated from the variables relations to object of interest, you don't need it.
Oh, right.
It's going to get out of sync.
Yes, I get you. But you know, yes.
It might be a simpler model.
Do you think, Siako?
I think this inverts again the intention. So if you see this has applicable as kind of constraints of which variables can be part of that set, then it carries a different semantic information than the ones that the variables itself carry. So it's about the interpretation of this has applicable. If you interpret it as a constraint to actually fill up the set, then you need it, then it's not redundant. If you do it manually by assigning all the variables, then I completely agree, then it would be redundant and could get out of sync.
It's whether it adds extra information that you cannot infer from the set relation.
So it needs to be an either or, basically, yeah? Either you use that relationship or you use the as applicable.
It's a matter of the definition of those has applicable properties. If they are defined as a constraint, telling you what should be in the set,
yes,
then it carries a different semantic information than this has object of interest on the lower end,
right?
Which is already an instantiation of that, more or less.
Right. Yes.
I just want also to mention, because we are closing now,
we're closing now.
that our intention is to also look further how to map or include IADOPT in any other measurement ontologies. There's not only observation measurement, there's OBOE, there are other approaches like EML, metadata languages, seeing how this could be somehow reused in this context. So there's a lot to do, and I'm happy to.
So I think the closing statement belongs to Robert, who said now in the chat that happiness is one of those variables.
Yes.
It is.
So I was very happy to do this today.
Thank you very much. Thank you for everybody online. I hope you were able to follow some of the discussions.
Yeah, you remember the last. So if you are interested to be invited in workshops, use the minutes, write your name so I can invite you.
Still to the end? Amazing. Yes.